So here's part two. So before we were talking about the universe and galaxies and the different things that you would find in them. Now we're going to talk about gravity and how it affects things within the solar system. So we know that gravity, we learned this with the forces, is a force that pulls something to the center of an object with the larger mass. Okay, so the reason why we stay on the surface of the Earth and get pulled towards the center is because of gravity. Okay, the reason why our planets orbit around the sun is because the sun has a much bigger mass than our planet. So gravity is a mutual force of attraction between two objects because of their masses and the distance apart. Everything has gravity, but larger objects have more gravitational pull to objects that are closer to them and have more gravitational pull towards each other. Okay, so this one down here, this explains why our moon revolves around our planet as opposed to revolving around the sun in an orbit similar to the planets. Okay, it is smaller. Okay, so the Earth has a larger mass, but it's also closer to it. So the closeness affects the moon's orbit. Okay, so we're going to continue to talk about gravity and why the universe is organized the way it is. Okay, stars have, and you're hearing my clock going in the background, stars orbit a central black hole because the black hole has an enormous amount of gravity. The sun is able to keep the planets in orbit because the sun is incredibly large and its gravitational pull reaches the planets despite the large distances. Planets are too small to orbit a black hole. Okay, so a galaxy, stars have planets that orbit around them in the solar system. Okay, so the star is going to orbit a black hole because it has so much gravity and the star is so big. Planets are going to orbit around our sun because in comparison they are pretty big compared to like the moons and asteroids and comets and things like that. There you go. Moons orbit planets because they are closer to the planet. Okay, so we've talked about this before, but weight is a measure of gravity. Now if you remember, next thing you'll see here is talking about mass. Mass is the amount of matter something has. Weight is the measure of gravity's effect on that mass. Okay? Because larger planets have more mass, then they have more gravity. So therefore they have more weight. Okay? Because larger planets have more gravity, you would weigh more on a larger planet. It's the same concept as if you go to the moon, which is smaller, okay, has less gravity, you would weigh less. So if you were come back to Earth, which has more mass, more gravity, you weigh what you weigh now. If you were to go to Mars, which is even bigger than the Earth, since it's bigger, it has more mass, has more gravity. So if you went to Mars, you would weigh more than you do on the Earth. Okay? One of the things that makes it challenging when you learn about space and the universe and things like that is it's really hard to imagine the size of these things because they are so big, but they are also so far apart. Okay? So what I have next to show you are some pictures to kind of help you figure out just how small we are. Okay? And just how big this thing called the universe is, which, by the way, keeps going on forever and ever and ever. Okay, so here's the small planets. So you have Pluto, which we know is not a planet, okay? Mercury, Mars, Earth, and Venus. You'll notice Earth and Venus are pretty similar in size. Okay. Jupiter, Saturn. Here's Uranus and here's Neptune. Here is Earth right here. Pluto, teeny tiny down there. Okay, so Jupiter, Earth. We think this is big. Just imagine if you were there and traveled around the planet. Okay, so here you'll see the Sun in comparison to Jupiter and all the other planets. So take a look. Let's go back for a second. So here's Earth. Here's Jupiter. Here's Earth. Here's Mercury, which is the closest one to the Sun. Okay. Notice this at the top of Mars, by the way. Okay. Here's Earth, Jupiter. And my son decides to push the screen when he's not supposed to. Okay, and then here's the Sun. So you can see in comparison to all the other planets, here's all the planets plus the dwarf planet in the solar system. Here's the Sun. This has a huge mass compared to these. So this is why our planets orbit around this thing. Okay. Now, here's our Sun that we think is so huge. Remember, look back here. Here's us right here. Teeny tiny little speck. Here's our Sun. Here's our Sun. Here is some other stars. Sirius, Pollux, and I guess that's Arcturus. On this scale, you would not be able to see the Earth. Jupiter on this is 1 pixel, so it's one piece of the paper big. Okay, here is our Sun, so 1 pixel, so one piece of the picture here. Let's see, let's go back for a second. Oops, wrong way. So here's the biggest one on this one, Arcturus. Here's Arcturus here. I'm going to say that's Betelgeuse. Okay, it's probably Betelgeuse, but we're going to call it Betelgeuse. Okay, so here is a galaxy. So all these little stars are these. Okay, so you see there are different masses of stars. Okay, so in theory, I guess you could have one star having other solar systems within it. Okay, here's your galaxy. What do you think all the white dots in the background are? Any ideas? Oops, what did I do? So what are all these little white dots in the background? All right, there's part 2. Thank you very much.